Thank you very much. This is quite a nice venue, this actually. Yeah. No. So I am Sam Beckham. I am at Sam D Beckham on Twitter. I'm not going to do questions at the end. If you have any questions, please send them to me on Twitter throughout the talk, and I will pick them up at the end. Yeah, I'm here to talk to you about making GitLab a PWA. I'm going to do the sort of about me section first. So unsurprisingly, I work at GitLab. GitLab is completely open source. So even if I didn't work there, I could still technically do this, but I wouldn't get paid for it. So why would I? Yeah, so more on what GitLab is a little bit later. And I also run Frontend NE, which is a meetup very similar to this, just a little bit further north up in Newcastle. We did a couple of conferences, and we've just had our 50th event. No, in fact, we've just had our 51st event last week. And we do them the first Thursday of every month. So if you fancy going a little bit further north on the first Thursday of the month, please do. We've got some cracking talks lined up. And if you want to give a talk at them, then come find me. We're always looking for new speakers. So I'm going to start this talk with a little bit of a story. And this is a story about the conference website from 2018. When I made this website, I knew that people are going to need to use it on the day of the conference. I also knew that the Wi-Fi was going to be conference Wi-Fi, so it was going to be terrible. And we were in the middle of a brewery, in the middle of a park, in the middle of basically nowhere. So the mobile signal wasn't great either. Long story short, people were going to be going to this website on terrible connections, so it needed to load really, really fast and be really reliable as well. So I did a quick benchmark before I'd really done anything too much on it. And on Wi-Fi speeds, we were getting about a second before the site had actually loaded, which isn't too bad. 3G will be a better measure of the kind of speeds we'll be expecting from the network. And we were getting it in about 3 seconds, which, you know, it's not great, it's not terrible. We can certainly do a lot better. So I did a little bit of work and added some JavaScript, and I will show you exactly what that is later on. But we managed to get the Wi-Fi loading speeds down from a second to 0.3 seconds, which is a 300% increase, which is pretty good. And it takes 0.35 seconds to blink, apparently. So this is loading faster than the blink of an eye, which is an incredible marketing metric, right? But again, 3G is a much better speed to test this on because this is what people are generally going to be, you know, the kind of network speeds people are going to be having. So 300% speed increase. We expect about a second. We didn't actually get a second. We got 0.3 seconds. Much better. Again, faster than the blink of an eye. And the reason for this is because it doesn't matter what network speeds you're getting, whether you're on Wi-Fi, 5G, 4G, 3G, 2G, Gina G, Ali G, doesn't matter. Because when you're offline, you don't get the Chrome dinosaur. You do unfortunately get our website in 0.3 seconds. And that's the speed that it takes to load the site from your actual device. So we were serving the site completely offline first and then accessing the network afterwards, which is why we're getting these crazy loading speeds. We were able to do this because we made the site into a PWA, or Progressive Web App. Bit of a buzzwordy term. So a slightly better way of explaining what this is it's just a website that behaves like a native app. So it's just a normal website. It's HTML, it's JavaScript, it's CSS. There's no compilation processes. It's not like React Native or PhoneGap or whatever the kids are using these days. It's just a website. And you can do some native app type things with it, with this little bit of extra JavaScript that makes it a PWA. And this is the one that we sort of, I guess, made use of, and that's installing to your device. So this is what you can do with an app. You install it to your device. You download all the files you need to open your app. It's not like adding a website to your home screen, which is just a bookmark to that website. It actually downloads and installs whatever you tell it to. So the HTML, the JavaScript, and the CSS. So you can just load that site completely offline. But it is just a website. There's nothing too fancy about it. And because it is just a website, it's also a progressive enhancement. So if you or your device doesn't support the things that it needs to become a PWA, it doesn't have the offline support, it doesn't have any of these things, it doesn't matter. You've still got a website. No one's losing out because you've gone down this PWA route. It's just a little bit of extra sugar on top that gives you all these nice things. So that was a very, very quick introduction to what PWA is. There's a lot more information out there. I would recommend you go out and look at talks by Jake Archibald, other people as well, but Jake Archibald is a good first port of call. And he has talks that go a lot further into detail about what these are. But I'm here to talk to you about how I turn something not like GitLab, but actually GitLab into a PWA. So a lot of these talks that you'll find on PWAs, they'll create a web app that's specifically tailored for being the ideal candidate for being a PWA, or like the example I use at the beginning, it's a conference website. It's a static site anyway. It's, like we're serving it offline. It's dead easy with caching some offline files, but I wanted to know how hard it was to make something as big and as complicated as GitLab into a PWA, because realistically, these are the kind of things that a lot of us do work on, and the things that would benefit more from being a PWA. So this is an example of GitLab. This is a merge request. So for those of you who don't know what GitLab is, I should probably quickly explain. The official term is that GitLab is the single application for the entire DevOps toolchain. It manages your repositories, it has issues. We have merge requests, which basically pull requests, just named much better. We have CI/CD built in. We have all sorts of different bits and pieces. And you can see from this screenshot that for that reason, just caching the page and serving up the cached page offline, it's not going to work. Because the second that you cache this page, it's out of date. Because someone could have commented, or your pipeline could have moved further along, or any number of things could have happened. It's instantly out of date. So we have a bit of a sort of mantra at GitLab, and that is to use the boring solution. So what is the smallest possible change that you can make to something that either gets you where you want to be minimally, or gets you on the right path to where you want to be? So as an example, we wanted to move our Rails and jQuery code base to using something more modern like Vue or React. And the idea of rewriting the whole thing in Vue and then shipping that as we were still adding new features, and this just sounds awful. So we took a small part of GitLab and we made that a Vue app. And then we took another small part of GitLab and we made that a Vue app. And then we kept going and going and going and making all these smaller parts, moving them away from the jQuery stuff and moving them into Vue. And now I would say the majority of GitLab is in Vue. And we could only do that because we did the boring solution first, and then we kept iterating on that and making it better and bigger. So what is the boring solution for our PWA situation? We should really start off with a list of things that we need to do that will get us where we want to be. And luckily, Google have already written that list for us. It's inside an application called Lighthouse, which was originally a standalone application. It then moved to a browser extension and command line tool and all sorts of things, but it's actually baked into Chrome now itself. So if you go into the audits tab of Chrome, you can run a Lighthouse audit. And it's a list of things that you need to do to make your website a progressive web app. And it runs a series of tests that tell you whether you've done these things or not. So I ran that on my profile on GitLab, and you can kind of see, this screenshot's out of date now. Chrome have updated Lighthouse slightly, so some of these things aren't quite what you would see if you were going to run it, but the idea is basically the same. You can see we've kind of got two lists here. We've got a sort of reddish list here and a sort of greenish list here. The greenish one at the bottom, that's all the things we've already passed, we've already done. And I've not done anything at this point, I've just ran the test. So a lot of these are just kind of best practice stuff that you should really be doing anyway. And then the things at the top, that's now our list of 5 things that we need to do to get that PWA status. There's not actually all that much to do. So this is basically that list, just on a slightly more readable slide. The things that we've already passed, as I say, mainly best practice stuff. Non-JavaScript content. Does the site load something without JavaScript? It really should. I'm not actually too sure what that is on GitLab, but there's something there at least. HTTPS and HTTPS redirect. Are you serving the site over HTTPS? If someone tries to go to the HTTP version, do we redirect them? Again, this is pretty much best practice now. Most websites are served over HTTPS. Fast enough on 3G. Fast enough just means on a simulated 3G speed, are we interactive in less than 10 seconds? If you're not hitting this, Lighthouse will help you. It'll give you some pointers of where you can go to get your speed, your page speed up. There's another audit in that same tab specifically for page speed as well. So if you're not hitting this benchmark, Chrome will help you out. Meta viewport tag. So this is the little tag that you put in the head of a website that you'll know it when you forget to put it in and you look at it on a phone and your nice responsive website is super zoomed out. This is the tag that you forgot to put in. Copy and paste it from another website like everybody else does. Or, again, if you don't have it, Lighthouse will tell you what it is, tell you where to put it. What's next? Size for the viewport. This is a fancy way of saying, is your website responsive? If your website's not responsive, stop what you're doing, make your website responsive, don't mess on with these. That's the first thing you should be doing. It's been, 10 years since responsive websites started being a thing. They should really be the standard now. So we have 5 things left. These are the things that we've not done. These are the things that we need to do. This is our list for our boring solution. Custom splash screen, themed address bar, service worker, 200 when offline, and prompted to install the web app. I should be able to make it to that last point in time. We'll see. Hopefully we will. But we'll certainly go through the other ones anyway. Custom splash screen. So we need one of these. What is a splash screen? This is a splash screen. This is Twitter's splash screen. This is what you get when you open up the Twitter app. You just get, it's only on there for less than a second. It's what it shows while it's loading the app. Again, because our site's loading in 0.3 seconds, you will get this for 0.3 seconds. So, but luckily it's pretty easy to make. And it's kind of paired with the themed address bar as well. You use the same technique to make both of these things. This is largely pointless. You're just changing the color of the address bar. I don't know why this is required, but it is, and it's an easy win, so let's do it. It kind of looks like this. So this is my very neglected blog. You can see I've just changed the color of the browser Chrome at the top to match the color of the post. It's nothing, nothing too fancy, and it's not too hard to do. And you do both of these with what is called a manifest file. So this is basically the exact manifest.json file that I used for GitLab. The only difference being that on the actual manifest file, there's a lot more icons in this icons array. But I've only shown one for brevity here, but the rest of it is exactly the same. We just specify a few things in this JSON file, and the browser picks them all up. So we specify the name, which in this case is GitLab, and then the short name, which is again GitLab. So there's a character limit on short name. I can't remember what it is. I'm going to say 25 characters and probably be very wrong, but GitLab's 6 characters, so we're fine to use it for the short name and the long name. Display standalone. This is the property that gets rid of the browser Chrome that we have to style and then remove. It makes no sense to me at all, but there we go, that's a thing. Scope and start URL. These are both set to the root. So scope says what files and what routes does this progressive web app have control over, basically. Most of the time, this is just your root. It can be, you can specify like a subsection of your site if you want to, but again, leave it at the root. It's probably your best course of action. Start URL, very similarly, just leave it at the root. You can set a page to, so when you open this app, it goes to a specific page, but most of the time you just want it set to the root of your website. Theme color. This is what colors the browser Chrome that we're about to hide, which again, not really sure why. I have rather naively chose a sort of nice grayish blue color, which is the same color as an incognito window. So kind of be careful when you're looking at GitLab, because you do look like you're in incognito mode. Background color and icons. This is what generates the splash screen. It just gives you background color. So like on the Twitter example, that would be that blue, and then the icon would be the Twitter icon. It just builds that up for you using these two things. And again, if you've got a series of icons in this array at different sizes, it just picks the most appropriate one and displays that for you. So manifest file, 16 lines, not too bad. All you got to do then is include it in the head of your page. So same as you would with the style sheet, just do rel of manifest instead of style sheet, and then link it to obviously wherever your manifest.json file is. And then that gets us custom splash screen, and you can sort of see the browser Chrome's been colored that sort of incognito blue. Nice and simple. We're halfway through our list, which, I mean, that didn't take long. That's 16 lines of code. It took me longer to talk about it than to do it, really, to be honest. 3 things left. We're going to tackle Service Worker and 200 went offline together in a similar way that we did with the splash screen and the address bar. And that is simply because the Service Worker is the thing that gives us a 200 went offline. So what is a Service Worker? In order to explain what a Service Worker is, I've got to go back to basics and explain basically kind of how browsers and servers work. Now, this is going to be really overly simplified. If you ever get asked this question in a job interview, do not give this answer because you will not get the job. A browser makes a request to a server, and then a server responds with something. That's it. That's my entire explanation of how browsers and servers work. It's overly simplified, but it's fine. You know, if you request a web page, maybe your server does some templating or whatever, and then responds with the required response. Maybe there's some authentication there. It doesn't really matter. All we need to know is that browsers make requests and servers respond with what's appropriate. And what a service worker does is it sits in the middle of these, and it can listen in at the requests, it can listen in at the responses, it can change them, it can fire new ones, it can kind of play about with them a little bit. So it's a really simple concept that you can kind of do a lot with. One example I did before, every request for an image went through a service worker, and instead of going to the browser and getting the actual image, it just sent a pre-cached version of Nicolas Cage back. So every image on the page was Nicolas Cage. It was really nice. Very impractical, but there we are. Yeah, so here's a simple example of the way that the caching worked, the offline caching worked for the conference website that I showed at the beginning. So a browser made a request for, in this example, a cat picture. The service worker heard this request and just passed it straight through to the server. It didn't modify it, it didn't do anything with it, it just passed it straight through as it was. And then the server responds with its cat picture, and the service worker just passes it straight back to the browser. As far as the browser's concerned, it's asked for a cat picture and it's got one. As far as the server's concerned, it was asked to give a cat picture and it responded with one, so everyone's happy. But what the service worker also did was when it sent it to the browser, also sent it to the cache. So that next time the browser asks for the cat picture, the service worker doesn't have to go over the network to fetch this picture. It can just get it from its own cache. So the browser, the service worker, and the cache are all client-side. They're all on the browser. So the cache returns the cat picture, and the service worker sends that back to the browser. And the server, it's not being asked for anything. It doesn't care. Obviously, there's some caching issues with this. Be very careful with this. You don't want to be serving everything in this way, because if you ever ship a new version of anything, no one's going to see it because they're going to be getting the old version from the cache. But more on that a little bit later. We want our service worker to give us a 200 when offline. Now, 200 is the HTTP status response for OK. So 200 when offline basically means instead of getting offline error when we're offline, do we get an OK response? Do we still get, on the conference website example, if we asked for the conference code of conduct, do we still get that code of conduct even when we're offline? Do we still get that 200 when offline? Now, as I explained earlier, we can't do it quite like that on GitLab because it's just, well, we can do certain things. We can cache the majority of the page and then dynamically load in certain bits. We can load in a cached version of the page and then go fetch the bits that need updating. There's all sorts of bits and pieces and little tricks that we can do, but I'm lazy and we're looking for the boring solution. So we don't want to do that yet. We want to do that eventually, just not yet. So we kind of need to get a little bit creative with 200 when offline. More so this 200 part. Now, 200 means, do we get a good response? Doesn't mean do we get the correct response. So what we can do is we can serve up an offline page. So it just says, you don't have an internet connection. It looks like your internet is offline. Maybe you're just going through a tunnel. We're working on adding offline support to GitLab, but it's not quite there yet. So we can serve this page, and this is a 200 response. This is a valid response. And that gives us that 200 when offline. So the user will see this instead of the Chrome dinosaur. It's not massively helpful, but again, it gives us that platform to build all the nice PWA stuff and add that caching on. It's a good first step. So how does this look with our little diagrams? So it's very similar to the cat one, but remember I said before that service workers can just make requests all on their own. They don't need the browser to tell them what to do. So the service worker can just make a request to the server for this offline page as soon as it's there, as soon as it's ready. And then the server, it just responds with the offline page as it would if the browser had requested it. And because the browser's not requested it, the service worker doesn't send it back to the browser. It just drops it straight in the cache, ready for another day, ready for when it's needed. And then when it is needed, when the browser requests an issue page, for example, and the service worker, it'll just pass that request straight through to the server. So normally, if that request's fine, it'll respond with the correct page. The service worker will pass that correct page back to the browser. Everything works as normal. But if that internet connection's not there, then the service worker knows that it can check the cache for that offline page. And the cache will respond with the offline page, and the service worker can respond to the browser with the offline page. So the browser's asked for the issue page, or the merge request page, or the profile page, or whatever. If we're offline, the service worker tells it, here's the offline page instead. We don't have an internet connection. Here's the fallback, essentially. So it's largely the same as having the little Chrome dinosaur, but now he's not got a job to do anymore. We've replaced him. He's extinct. So it's all well and good showing you this in nice little flowcharts. I want to show you just how easy it is to do with the code. This is going to be the actual code that I used on GitLab. There's not a lot. Don't worry, this isn't all of it. There's not a lot, but this is, it's cut off the line numbers here. So, but the idea is there's this file and another file, and combined there's like 35 lines of code or something. It's not a lot. So we want to register the service worker. So we check if service worker in Navigator. So if the browser supports the service worker, then we go and register it. If it doesn't matter. We don't care. It's just a website. Everything works as normal. If it does, great. Let's go register it. That scope thing, if you're interested, ask me about it later. That's a bit of a rabbit hole. But again, set it to the root, same as we did in the manifest file. And then this is the service worker itself. It's 30 lines of code. This is exactly the service worker that I used for GitLab. The majority of this is cache busting. It's just this little block at the bottom here that does all the fancy stuff. And there's 4 distinct blocks. There's this one at the top, which is just some constants. So it's where the offline page is. It's the name of the current cache. We're naming our caches. That's how we're getting around the cache busting issue. And then the other 3 blocks are event lifecycle hooks. So much like you have component mounted or props updated or whatever in React or Vue, service workers have their own versions of these. And we're interested in the install event, the activate event, and the fetch event. So very quickly, this is what the install event looks like. We just generate a name from the current version of GitLab and the current revision of GitLab. So this is the commit hash. So we're busting the cache every time there's a new version shipped. And we say on the install event, open a cache with the name of the current cache name that we've set. And then we do cache.add offline page. And that's all we need to do to go fetch that offline page and drop it in our caches. The service worker just takes care of everything and does it all in the background. There's no libraries or anything here. This is just a service worker. This is just JavaScript. Then once we've got that offline page stored in the cache, so this was the install event, there's then the activate event. So activate is what happens after it's installed. So once the service worker's installed itself, if there are no other service workers running on the page, it'll activate immediately. If there is another one running, it'll wait until you reload the page or you open it up in a new tab or whatever, and it will activate itself so that it replaces the old one. And at that point, all we want to do is loop through all of the caches and just delete all the old ones. We don't care about them anymore. We're not going to use them anymore, so let's delete them. This looks more complex than it is. It literally is just a loop that says for every cache, if the name is not the current cache, delete it. Once we've done the activate event, we just sort of sit idle and we wait for a fetch event. So this fires anytime anything's fetched, whether it's an image, JavaScript, a page, whatever. But because we don't really care about images being fetched or JavaScripts or CSS or whatever, we only care about page requests. We want to pull out the request from the event, and then we want to pull out the method and the mode from that request and just say if it's a GET request, so if we're fetching something, and if it's a navigation request, so if it's specifically a page, it's not, it's not any assets or anything, then we just say event, respond with our own fetch request that's just passing in the same request parameter that we pulled off the original one. So it's exactly the same request. If it's successful, you can add a .then and do whatever you want with it. But because we just want to do the default behavior, we don't have .then. We just want to catch that error, that offline error. And we say, caches, go fetch me the offline page. And that's it. That's all we need to do. This is the entire service worker that does what I outlined in that flow chart. And that gives us basically everything we need for to pass the Lighthouse test. This is the majority of our boring solution. Completely done. Now I have 1 minute to explain this last one, which is a bit of a doozy. Prompted to install the web app. So what this does is when you're browsing the page or browsing the site, if you're interested in it, it'll give you a pop-up, and we need that pop-up to say, okay, do you want to add this to your home screen? Do you want to, have that sort of native app type experience? Because obviously there's no app store for websites. It doesn't work like that. You have to go to the website, browse it around it a bit, and then download it. So I've tried to fit everything you need to do on one slide. Are you ready? We don't need to do anything. It's fine. Come on, that's funny. Come on. Thank you. We don't need to do anything. It's fine. Chrome does all this for us. It works out. It runs Lighthouse in the background, and it runs all these tests, and it knows you've got all of these things, and it uses probably machine learning to work out that you like the website that you're on. And it sends a little prompt to you. It's really nice, really simple. And we're done. That's the entire checklist done. and it's not a lot of code. It was like, what, 46 lines of code or something. It's incredibly easy, even for something as big as GitLab. The size doesn't really matter if you're just doing this small, boring solution, quick step. So this is what it looks like running locally. If I tick the offline box and then go offline just to show you there's no smoke and mirrors, we do get the Chrome Dinosaur game. We are actually offline. And then if I load GitLab, I'm running this locally, by the way, which is why it's at localhost and why you have that bar at the top. But the service worker activates and registers in the background. You can see it in our application tab here. And then if we go offline again, when we try to go to another page, we get our offline page. Happy days. And that's all we need to do to get that first step towards being a boring solution. And this gives us a sort of mobile app type thing for free. So this is just the website kind of thing. I've had to add it to my home screen because my local version is not over HTTPS. So I actually fail Lighthouse on this one, which is fun. But it still does most of the stuff. And you see, we can open up GitLab as a proper app. We get our splash screen. And then we've got the GitLab app, which is just the GitLab website. And any updates we ship to the GitLab website is now on the GitLab app. And this is all for free. This just happens with what I showed you earlier. And also for free, in the same vein, Chrome now has certain flags so that you can download it and add it to your desktop. So you can see kind of over here, we've got a little Tanuki, and it is just a normal sort of desktop app that runs inside Chrome. We don't need to mess on with Electron or anything mental. It's just there, and it's for free. If we don't want this, it doesn't matter. We don't need it. We don't need to support a desktop app and a mobile app and a website. We just ship to the website. It's fine. So this should be coming in version 12.1, which ships on July the 22nd, which you may realize is in the past. I missed my deadline. So I just want to say it's coming soon-ish. I had some issues with RSpec tests, which is the Ruby testing suite, because when you give it an offline page and it's expecting an error and you give it a 200 response, it's not happy. So there's some little bugs I need to iron out there, and it's all with the testing. The actual thing took me 20 minutes. As ever, you'd spend the majority of your time fixing the tests that you've inevitably broke, but here we are. It is open source. If you want to Google it, you will find the issue and the merge request and everything on there. So if you're good at RSpec tests, please do come and help me out with them. I'm a little bit stuck. And yeah, that's it from me. Thank you very much.